Hi, happy to be with you today virtually. I am a professor, researcher, writer, occasional consultant, and I do work in the area primarily of artificial intelligence and how it affects how people do their work. And I've been doing a series of projects involving what I call the future of work now, about particular individuals who work with AI on a day-to-day basis. And I heard something about Lilt and approached them to see if I could interview a translator, a computer-assisted translator, to see exactly what work is like in that regard. And so now I know just enough to be dangerous about localization and translation, the state of the art. I'll talk a little bit about that today, but I will also talk about a number of other contexts in which this is happening, and then say a little bit in general about how AI is changing our work. So you probably know that a number of quite intelligent people are worried about AI, both because it may kill us all, which seems to be the Elon Musk and Stephen Hawking approach. The late Stephen Hawking, he was concerned about it. I guess he's not now. And there is a considerable camp of smart people who's worried about what AI will do to jobs. Bill Gates doesn't really say why he's concerned about super intelligence, but Bob Shiller, Nobel Prize winner from Yale, said advancing machine intelligence is the most important problem facing the world today. I'm not sure I agree with him on that. I might put, political leadership and climate change ahead of him, but ahead of that problem. But he's talking about what we will do job-wise from advancing machine intelligence. And then a couple of Silicon Valley people, Michael Malone and who's a writer, and Bill Davenport, who's a venture capitalist, I believe I have that right, said, we'll soon be looking at hordes of citizens of zero economic value, and they'll be rioting in the streets and so on. So a lot of people are worried about this. I am less worried, I will say, although I think there is some cause for concern, and I'll elaborate on that. I think it's important to remember that even if AI does end up eliminating some jobs, it has a number of other desirable attributes, like curing disease or increasing our productivity dramatically, which we haven't really done with other recent technologies. We really need some productivity, or solving a whole variety of social issues, like how to get old people around and mobile without them having to drive, or maybe we'll eliminate urban congestion. I'm not sure I believe that, but we don't have enough people to assist patients in hospitals, so maybe that would happen. And AI, I think, could lower the cost of university education, although it hasn't much yet. And then we could get that long promised benefit of personalization of advice, content, and marketing. So we actually want to receive some of the digital ads that we receive. I got one recently for a restaurant I really love to, and it almost brought a tear to my eye. It happens so rarely that I get something I want. And it's also, I think, important to remember that pure automation, the replacement of people by machines, has kind of been a pain all the way back to Charlie Chaplin. When we've tried to fully automate systems with previous technologies, the outcome has been disappointing. Interactive voice response is a pretty good example, where we're constantly pressing the zero button to get to a human. Facebook trending topics was a big failure. A lot of these over the years, and in many cases, I think humans prefer to be served by humans when they can be. It's not the most efficient thing to do. Automation can be a race to the bottom, where you lower your own costs, but everybody else in the same industry ends up doing it as well, and you lower your costs, your margins, your profits, etc. And it's difficult once you automate a process to change it. So combining automation with creativity and frequent innovation can be a tough thing to do sometimes. So perhaps for these reasons, perhaps just because the technologies haven't been up to snuff, automation has been slow thus far to replace jobs in the current world. I'll talk about history in just a second. Right now, we're okay, but I think there is this general concern that we've seen previous patterns of job elimination in the 18th and 19th centuries with manual labor jobs, and to some degree in the 20th century with administrative and service jobs. We don't see nearly as many airline reservations clerks or travel agents. Bank tellers still seem to be necessary. We haven't really lowered those numbers much, but in all those previous eras, we could say, well, don't worry, we can just go upstream to knowledge work jobs because, if you think for a living, computers will never be able to replace that capability, but now they are replacing that capability, and those kinds of knowledge work jobs are just the thing that AI is coming for. So is knowledge work the next to be automated? I mean, my highly unequivocal view is yes and no. I sometimes could be an economist with that level of indecision rather than the sociologist that I am. But it's certainly true that many knowledge work job tasks are at risk of being automated and have already been automated in some cases. The good news is that almost all of us in our jobs do a whole variety of tasks, and AI, being the sort of narrow thing that it is, at least for the moment, typically doesn't automate an entire job, or certainly not an entire business process. So what the task issue does mean, though, is that some knowledge workers might lose their jobs kind of on the margin. So if we can automate some aspects of legal work, which have been done, there's this whole area of e-discovery and predictive coding of which terms are going to come up in corporate litigation documents. Well, maybe we'll need 8 lawyers instead of 10 in the future, which many people argue might make us a less litigious society. Job loss will happen slowly. As I said, bank tellers, we have the same number that we had in 1980, even though we have ATMs and home banking and so on. The good news is I think there are going to be a lot, nobody knows exactly how many, even though you may see some predictions every now and then, of jobs that involve working alongside smart machines. And this is my particular area of interest. And the other good news is if we do this well, we would have lots of productivity gains, so we could afford to retrain people and redeploy them into other jobs if we wanted to, or if things went really well, we could afford a guaranteed minimum income for everybody. It's hard to imagine that happening in the US in the current political climate, but people are experimenting with it in places like Finland and so on. It does seem to be working reasonably well. I guess we have one experiment in Stockton, California, of all places. But in general, I think there's no room for complacency here. And we all have to kind of think about what might we do if key tasks in our own role were taken over by smart machines. So that's really the issue of augmentation. And I like that term a lot. I like the idea much more than large-scale automation. It means that smart humans help smart machines and vice versa. People would do this by helping out automated systems that are better than humans at their particular tasks, or by focusing on those tasks where humans are still better. So, that may in some cases be the machines doing 80% of the work and the humans kind of checking on them doing 20%. Or in some cases like robotic surgery, the humans providing 80% of the value and making all the key decisions and taking the key actions, and the machine, the robot, in the surgery case, is doing the 20% or so and giving the human some superpowers, if you will. So again, the good news is that most organizations today, and I see a lot of them, I talk to companies every day pretty much, are pursuing augmentation or saying that that's what's happening. We're freeing up humans to do more interesting, more complex work, and we're just taking over the boring stuff. However, there's kind of a conspiracy of silence about this automation idea. And I worked with Deloitte on a survey a couple of years ago where 63% of the US executive respondents who were familiar with AI said, we plan to automate as many jobs as possible to cut costs. So it could be coming, and again, no room for complacency. So what I did a few years ago was to think about, this is in a book called Only Humans Need Apply, with Julia Kirby, was try to develop 5 ways of sort of adding value to smart machines. And I ended up calling 5 ways of stepping. The most common by far, I think, will be stepping in, where humans sort of know how these automated systems and smart systems work, know their strengths and weaknesses, when they need to be modified. And I think that will be the bulk of the kind of augmentation-oriented jobs. But there's also stepping up, where it's kind of a managerial role, where you sort of look at the big picture and say, well, we have this automated, but not this. Where do we need to add more? There is stepping aside, where humans do the things like creativity and empathy and so on that they do better at computers, at least for the moment. Anyway, the balance of capability is always changing. I realized that there were some jobs that are so narrowly defined that you could have an option involving just be really narrow in your orientation. So my first awareness of this was, I was reading an article in the Boston Globe about a guy. All he does, makes a very good living, drives a Rolls Royce around the streets of Boston, which is kind of nutty. But he connects buyers and sellers of Dunkin' Donuts franchises. That's all he does. And, we know computers are very good at connecting buyers and sellers of things, but that is so narrow that it's unlikely somebody would say, I'm going to automate that process. So, you find the really small niches. And then finally, somebody has to build these systems. I call that stepping forward, where you build the automated systems of the future, or, improve their function through writing some new code or whatever. These are, very technical jobs. So these are 5 options. Some people have said stepping out, you should retire when these things are hitting your job. But in general, I think those are the 5 key possibilities. So I'm going to give you some examples, and I'll start with one that you all probably know a lot more about than I do. As I say, I've learned just enough to be dangerous. So what Lilt does? It uses machine learning to enable faster and more accurate computer-aided translation, computer-assisted translation and localization. So Lilt connected me with a woman named Erica Storm, who's Danish, but had just moved to New Zealand, and she translates for Lilt using their tool and specializes in marketing-oriented translations to and from Danish, although she speaks some other language as well. And she knows the strengths and weaknesses of different tools. A good example of sort of stepping in. She says, I've worked with a variety of these systems, but most are too stupid to really bother with. There's kind of an ecosystem of jobs. Lilt has a project manager who kind of assigns and monitors the work. And then there's a client. In this case, the one I interviewed was Alessandra, or she goes by Alex, I guess, Benazzi. I told her I liked Alessandra much better, but she's the head of global localization at ASICS Digital, business unit of the Japanese company ASICS. They have Runkeeper and a variety of other tools. And she kind of steps up to decide, well, what AI capabilities do we need to really get this localization done? And both she and Erica like Lilt and think that it adds a lot of productivity, and it's really well suited for the kind of localization work that ASICS Digital is doing. So they're quite happy with it. And then, of course, you have data scientists at Lilt, starting with the 2 co-founders who sort of step forward to train and improve models, both in general and for each customer and individual translator. So a lot of people working together to make this activity of localizing language a much more productive and effective activity. So some other examples. Morgan Stanley I've been following for a while, big investment and wealth management firm, and they developed a system, you might call it next best offers. That's what they call it. Some people refer to the whole area as robo-advisors, but it works with their wealth management customers and their wealth management advisors to produce investing ideas. And it used to take an advisor 45 minutes to come up with an individualized idea for a wealth management customer. Now it takes 1 second, basically, and the average financial advisor has 200 or more clients, so hard to do it in the old way. This system uses machine learning, identifies an opportunity to invest. The financial advisors decide, do I want to send it or not? They have the ultimate decision-making power. And the good ones, I think, are clearly stepping in. They understand, every system has some weaknesses. They understand what's good and bad about it. They've done some research at Morgan Stanley, and they have concluded, the key to success as a financial advisor is how do you engage with your clients at scale. So in addition to the AI capability, they also built a communications platform that they say just as valuable as the recommendation engine. Some people use the communications platform and not the recommendation engine. I think the most effective ones use both. 11 million messages went out through this next best offer system in the first 2 months of COVID. You can see how it'd be really valuable when you can't see a customer face to face. Jeff McMillan, who's the chief analytics officer for the wealth management group, it's kind of a step forward guy, said, we have this great machine learning algorithm, but in the end, financial advising is a human-based game. If all the system does is remind customers that the advisor is there and looking out for them, then that's often enough, to build that engagement. So interesting combination of human and machine-based capability there. Another company in the insurance business, Haven Life, is a business unit of Mass Mutual. They've kind of redesigned the term life insurance process to get fast and easy digital underwriting of life insurance policies. The idea is to avoid blood draws whenever possible. Nobody wants to have a nurse come to your house and draw your blood. So they try to figure out, can we give a policy without that? And so this uses a couple of different AI technologies, a rule engine and machine learning. About half the applications for life insurance don't even need any human review. They're done automatically. 20% don't need a medical exam, no blood draw necessary. The underwriter who I interviewed, a woman named Kristen Wanapane, said, this really speeds me up. I typically see that the system only flags a few risk issues out of 100 different possibilities. So the ones that are left for her are the somewhat more complex ones that the AI system can't figure out. Like, if prescription records show that a woman has been prescribed ondansetron, which is an anti-nausea drug, she has to figure out, well, was that because she was pregnant or because she had cancer? So it requires a little digging typically. Kristen, says, I'm not too worried about losing my job. She thinks complex cases will always require some human review, and we can take kind of the big picture perspective, which, again, machines are not terribly good at. Another example in the insurance industry, this is health insurance or electronic medical record systems and so on. There's something, I don't know if you're familiar with this, the International Classification of Diseases. I think it's a fascinating area. We're on the 11th version now. Most companies organizations using ICD-10, but ICD-11 has been pretty much developed already, be implemented soon. There are 14,000 codes in ICD-10, 55,000 in ICD-11, and then there's some other country-specific codes. The US actually has a couple of 100,000. It's virtually impossible for any human to keep track of all of these and remember what code is used for what, so you could end up looking it up. It's very time-consuming. So Optum, a big subsidiary of United Health, has a AI system that helps do this. It suggests codes for a case, and then the human coder looks at what the computer has suggested and said, yeah, that makes sense, or not, they're missing something here. The coder I interviewed said, yeah, it really improves my productivity. However, if you're not careful, the system can make you a little lazy because she's really just auditing what the system has done. She said, in a way, this has increased the requirements for expertise, the same thing at Haven Life, because everybody wants experienced coders or experienced underwriters. She said, I'm amazed sometimes at how accurate the system's coding is. Sometimes it makes no sense. So, you have to go in and correct it. She also feels coding will never be fully automated. So you can see how that would help a lot and would also increase the requirement for expertise. I recently did this case study with another co-author, Steve Miller, at DBS Bank, the largest bank in Southeast Asia, based in Singapore. And you probably know almost all banks use anti-money laundering software. There's a legal requirement. These are rule-based systems. They're not particularly flexible. They have way too many false positives. You don't necessarily want to accuse your client of money laundering unless you're pretty sure that he or she has done that. So there's a lot of human review necessary before you would approach a customer. So what DBS did, in addition to the rule-based system, they added a machine learning system to really prioritize the cases that the AML system ended up identifying positively. And they also built a system to look at networks among customers, fraud rings operate in networks, obviously, and a workflow platform that brings all the data together to make these decisions. They say they're about a third more productive in terms of the time they need to analyze a case, and they use a lot more data since the data is all brought to the application on this platform. They can much faster identify the bad actors. That's a term they use a lot. If a case looks like it's really improbable, they put it in a freezer for 90 days and just see what happens. So the head of transaction surveillance said, we have used these AI methods to augment the ability of our intelligence and our investigation analysts to make the right decisions, but we don't fully automate the process. It's really augmented intelligence, another form of AI. There will always be a subjective element to evaluations of what is and is not a suspicious transaction. So humans and machines working very closely together with a lot of effort to build these systems to make it happen. Just generalizing a bit about what happens in these augmentation environments that I've been studying, hoping to write a book about this before too long. Clearly, it takes a village, that old line, to make augmentation happen. Not just the step in people, but the step up people to kind of look at the entire big picture, and the certainly the step forward people without whom the systems wouldn't be built in the first place. So what usually happens when I go into companies, what happened at Lilt, they said, well, yeah, we can furnish you with a translator, but maybe you should talk to a project manager too. Maybe you should talk to the client. So you see that a lot of people are working together to make this a reality. I don't know if this is bad news or good news, but AI doesn't necessarily make our work easier. It often makes it harder, at least more intellectually complex. As the woman at Haven Life said, all the easy cases are done by the system. What's left for me is the hard cases. It's a much more stimulating job, but at the end of the day, my brain is kind of worn out. AI often does some prioritization. It figures out, like the anti-money laundering cases, which ones really need the most attention. It assembles all the information. Sometimes, one of the boring things that AI does is extract information from a lot of different places and put it all together for you. And it may make provisional decisions, as in the coding area. But typically, if it's important, somebody's going to need to take a look at it. I think one of the big challenges in this area is, if we're all giving the easy task to AI, what happens to entry-level workers? It was always a bit of a challenge in the last decade or two anyway, for people to come into the workforce as work gets more complex. I think it's going to get even more difficult because those entry-level tasks are being done by machines now. So how we create the experts and the experienced employees of the future, I think, is a big problem. Not sure anybody's really acting on that much yet. As I said, multiple types of AI are often combined, rules and machine learning, for example. In addition to the AI, you need to sort of move the work along, bring the data to it. So typically people develop workflow platforms at the same time that we have this intelligent decision making from the system. And for what it's worth, we're all working virtually now, but these people, for the most part, not the bankers, but virtually everybody else was working virtually. And you bring all the information to you over a network, so you can do it whenever you want, and tends to give people a lot of autonomy in their jobs. So what can you do if you're a threatened knowledge worker? Well, I think the first thing is make an early decision about how closely you want to work with machines on a day-to-day basis. And if you do like working with machines, then great. I think there are going to be a lot of these kind of step-in oriented roles. I've described some of them. If you don't, then you need to pursue either the step narrowly roles or the step aside roles, pursuing things that computers are not particularly good at or that nobody would find it economical to automate. My guess is there will be fewer of those and that they won't pay quite as well. That's historically been the case for jobs involving a lot of direct contact with other humans. I don't think we pay nurses nearly enough, for example. And also for jobs that involve a lot of creativity. We don't pay people in the arts terribly well either. But, I think all these decisions have viable outcomes. You just have to decide what you want to do. Think about how likely it is that a smart machine can perform your job tasks. And if you think it's pretty likely, then you better start preparing for this right now. So get busy, work hard to understand how computers make decisions and take actions. Some people have described this as developing a digital mindset. It's hard to know exactly what the jobs of the future are going to look like, but it's pretty clear that some strong digital and technology orientation is going to help a lot. So if you don't have that, you might want to cultivate it. Self-educate or advocate for your organization to educate you. And, if all else fails, it turns out AI is not very good at kind of looking at pipes and how they connect, and robots aren't very good at doing those kind of fine motor skills. So plumbing is a good idea, and you don't want to do the really kind of hardcore industrial stuff. You want more artisanal plumbing, and so I have an artisanal plumber's helper here. So with that, I will stop and am happy to answer any questions that you may have.